So I'm super happy to be here. My name is John, and I'm an iOS developer at Spotify. And I couldn't have a better talk before me talking about how to build components and how to create really good design systems for your apps. So today I'm going to talk about exactly that, how we can build component-driven UIs natively for mobile. Focusing a little bit specifically about iOS, but the techniques that I'm going to talk about today applies for both iOS and Android. So in case there are any Android developers who accidentally found their way into this room, well, hopefully you're going to get something out of this talk as well. Alright, so as developers, we're always looking for ways to make our development process faster, easier, and actually quite, more fun. We want to have fun at our jobs, right? And we're always looking for ways to go quicker from having an idea, whether that's an idea of a new feature in our app, or whether that's a brand new app that we want to just build and ship on the App Store. So we want to go through this process as quickly as possible, because if we lag behind, well, a competitor might do things faster than us, or someone might, beat us to having this great new idea for our app. And the great news is that over the last few years, we've had a lot of great, awesome tools being developed by the community to actually make this process a lot more smooth. We've had package managers such as CocoaPods and Carthage being introduced, where you can easily pull third-party code into your app. We have tools like Fastlane that make it easy to build and test and ship your app with just one command on the command line. Is quite amazing. And of course, the Swift programming language, which enables us to write more predictable code with less bugs, and that is more easy to read as well. At least I think so. And then we have a lot of great patterns that have started to emerge, especially on iOS over the last few years, with things like protocol-oriented programming, MVVM, and new ways of doing reactive programming as well, using things like promises or RX or operations, and dealing with asynchronicity in your app. So we've made a lot of progress, and development has become a lot faster over the last few years. But there's one area where I feel like we haven't made such a big, tremendous change over the last few years, and that is UI development. Now, don't get me wrong, we've had a lot of awesome tools, especially from Apple, to make UI development better. For example, auto layout, size classes, stack views were introduced just a year ago or so. So there's been some improvements. But at the end of the day, we're still doing UI development pretty much the exact same way now as we were doing it back when the iOS SDK was launched. So what I mean by that is that every time that we want to create a new screen in our app, we go to Xcode and we create a new UI view controller subclass. And we tend to always do this from scratch. Just subclass UI view controller and start writing our UI pretty much from the ground up. And when we do write this UI code and these view controllers, we tend to fill them with, well, pretty much the same logic in all of them. We have something like our UI table view data source and our UI table view delegate, or collection view data source and delegate, which does pretty much the same kind of data binding code type in pretty much every view controller. We do things like data loading or checking our caching, doing layouting our subviews, things like that. So our code tends to be pretty hard to reuse, and it tends to be pretty hard to adapt. And that's why we see all these view controllers in our apps, and view controllers tend to also become quite big because they have such a big responsibility. So just to give you an example, let's say we wanted to build an extremely simple UI. Let's say we just wanted to create this very, very simple table view that just contains a list of beautiful cities from around the world. Well, just to make things a little bit more interesting, because we could just pull this in from an interface builder or a storyboard and just be done with it. But it wouldn't be a pretty interesting app, because we'll just see a static list of cities. Well, no user would want to use that for a long period of time. So we're going to introduce a little bit more of dynamism here, where we want to call some form of backend service to actually get this list of cities. So you can dynamically update, maybe every day or something like that. So what are some of the bare minimum steps that we would need to do in order to build this UI and to ship it to our users? It looks extremely simple. It's just using a normal UI table view, no custom subclasses, nothing like that at all. But it turns out there's quite a few steps that we need to do in order to make this happen. Not only do we need to set up our table view or set up our view controller, but we have to do things like loading data and handling offline, handling what if there's a bad connection, or what if our backend returns an error code. We have to parse our JSON somehow. We have to, cache that and do cache validation maybe. Then we have to do things like bind this to our view, so we need to implement like this data source and this delegate. So it turns out that even for this extremely simple UI, it's hard to imagine a more simple one. There's quite a lot of tasks involved. And again, we tend to do this every single time we create a new screen. We tend to go through most of these steps. We might have some libraries that help us with tasks such as JSON parsing or caching, but we still tend to implement it manually in every view controller. So let's say we do this now. We build this UI and we're ready to ship. But then we realize that, it doesn't look very interesting actually. Like, it's just a list of text. It doesn't really look like it had a lot of design love. It could do a little bit better. So we go ahead and we ask one of our designer friends to help us out and say, maybe you can come up with an idea to make the UI a little bit more interesting in an easy way. And our friend comes back to us and says, you know what you can do, which will be very easy? You just take 2 images and just put them in top of the table view, and it's going to look much better. And yeah, it does look much better. It looks more interesting now. It's still pretty basic, but it looks good. But here comes a problem for us as developers, where we were using UI table view to implement our UI before. And here all of a sudden, we have 2 elements that are not so easy to express using a table view cell. Sure, we could do things like put both of these images in a custom cell, or we can do things like use a collection view on top of the table view or something like that. But we have to add complication to our view. We have to keep implementing things manually, and it adds to the complexity. It gets even worse when we keep introducing new things. So let's say the designer comes back to us again and says, you know what, I've realized that what this app needs, just like any other app, it needs a social elements. So let's go ahead and introduce a social element. Let's introduce like a list of friends, or like a row of friends that you can get in the middle of the table view. Wouldn't that be cool? Well, it would, but again, it adds complexity. Again, here we have to introduce maybe like a nested collection view here in the middle of the table view, and all of a sudden we have a quite complicated UI. And if you go to Stack Overflow, you will see that one of the most commonly asked questions about iOS development is how to mix a UI table view with a UI collection view. And people have all sorts of crazy ideas of, yeah, take the collection view and put it inside a table view cell, and take the cell and transform it. There's a lot of techniques you can use, but they all add complexity. So as we can see, as the more we experiment and the more we try out new UI ideas and let our imagination roam free, we see that the complexity of our UI code becomes just more and more and more complex. And that could end up being a problem and a blocker for us if we want to move really fast. So instead of having to do this, instead of having to just hardwire these behaviors into our view controllers, wouldn't it be a lot nicer if we could write our UI code like this? If we could just declare what we want to render and then have it being rendered for us. If we could just specify what elements we have on the screen or what components, and then we would just have some form of automatic system that would do it for us. That way we could specify that we want 2 images on the top, then we want to have a couple of rows, then we want to have 4 users, and then some other rows. That means that if we wanted to, for example, run an experiment where we move the user row to the top, well, all we would have to do is move it in the array, and then the UI would update. That would be pretty fantastic and a lot simpler. Basically, what we're looking for is just for an easy way to just render some form of state. Because if we think about it, isn't that really what we're doing when we're doing most of our UI development? We're calling some backend service or running some code locally. We're getting some form of state, some representation of the state of our app, and then we just render that. Wouldn't it be nice if we could just do that? Wouldn't it be nice if we could really kind of express the relationship with our state and our UI to say something like, the UI is a function of our state? Now, I'm a bit of a math nerd, so for me this looks extremely beautiful. And this is kind of what we're going for when we're talking about component-driven UIs. We want to create a very simple and easy relationship between our model code and our state and our UI. Change the state and change the UI. That's what component-driven UIs it's all about. So in fact, at Spotify, we've been super busy migrating to this exact architecture over the last couple of years. We've transformed most of our UI to use this exact approach, to just be a representation of the models that we want to render. So all the views that you see here, these are just a sample of some of the views from the Spotify app. They all use the exact same view controller. You wouldn't guess it when you look at it, because they look so different. Some of them have headers, some of them are rows, some of them are cards, but they're all just a representation of the state that they want to render. So it seems like quite a big leap to go from the kind of traditional way of building UIs, especially on iOS, where we build these hardwired view controllers, to doing something like this. So what did we need to do in order to make it happen? Well, we needed to go through 3 key steps in order to change our application to work in this way. And the first thing we needed to do was to create a shared data model. So in order to be more dynamic, in order to be able to basically render any representation or any model that we have, we needed to create something shared that we could use for any component that we might have. But if we go back and look at our, again, very simple app, we can see here that already in this extremely simple example, we already have 3 unique types of models. At the top, we have something that we represent using an image, and we might create an image struct to represent that with a URL for the image. We then have a cities model that has a name of the city and the country that the city is in, that we then use to create these rows. And then finally, we have our users, which also they have names probably, and some form of image URL here that we're rendering in the UI. So how do we write some kind of more generic data binding code that could take all these different models and just render them? Well, we have to come up with something more shared. And the name we chose for that was component model. And this probably is not surprising, given the name of this talk is Component-Driven UIs. So the component model is a more generic way to represent something that we want to render. And it's a way to fully decouple your model layer from your view layer, where you can keep your core data models private to your model layer and just communicate with the UI using component models. And then we're going to use a view model to encapsulate all these component models. So we're using a familiar pattern here, so some sort of MVVM, to make sure that we can communicate with our UI. So what does this component model contain? Well, it is pretty much the same model as we had before. It's just a little bit more generalized. Instead of saying name, we say title. Instead of saying country or last name or something like that, we say subtitle. We have an image URL, and we have a bunch of other properties that we then can use in our UI, but they're more generic, so they're not so specific to one of our core data models. So having a shared data model was the first step. The second thing we needed to do was to create protocol-oriented views. Now, I'm a huge fan of protocol-oriented programming, and I think many of you guys might be as well. And we can see it, especially in Swift, all throughout the standard library. Protocol-oriented programming is used to really share a lot of code. Instead of hard-coding behaviors into types, we have instead protocols that define characteristics, and we can then extend those protocols to define behavior. And we wanted to bring the exact same way of programming to UI development, which has traditionally been very subclass-based and very hardwired. So how do we do that? Well, if we look at here is one of the views in the Spotify app. Here's the browse view. And you can see here that what we tried to do was to split this up into more atomic pieces or building blocks that we can then use wherever we want in our app. And again, the name shouldn't be surprising. We chose the name components. So components are, instead of building a piece of UI specifically for a single view controller, it's just a single slice of the view that we can then use wherever we want. Components are not context aware, so they can just be used in whatever context that we desire. So how are we going to put all these together? If we have all these loose components, how are we going to fit them together to actually form something consistent and nice? Well, we're going to use UI collection view for a couple of reasons. First of all, it's a platform standard. We all know how to use UI collection view. It's a familiar tool. But second, it's super powerful. I don't know if any of you have tried to write your own UI collection view layouts. I personally think it's a lot of fun. I know I'm a bit weird. I also like JSON parsing, so yeah, I don't know. I'm a strange person. But it's very nice and functional way of defining layout for a view, because you just have input and output into this UI collection view layout. So what did the protocol look like that we created? Because I just mentioned we wanted to create more protocol-oriented views. Well, we started very simple. We just created a component protocol that contained a view property. So it's just a wrapper around any UI view that you want. It can be, UI button, UI switch,
UI table view cell, whatever you want. And then we used a method to load this view lazily. So we were a bit inspired by how UI View Controller works, that it lazily loads its view, so we don't have to instantiate all the views up front. What we're then going to do is take this view that the component gives us and put it inside of a UI collection view cell. That way, the implementer of this API doesn't have to always implement the UI as a UI collection view cell, but it's because it's quite limiting and can instead use everything that UIKit has to offer, and we're going to take care of the complexity of putting it inside of a collection view. We then needed a way to use this component model to bind our data to this view. So we introduced a configure with model API where we're going to give this component the component model from before and then ask it to bind this data to itself. The next thing we needed to deal with was layout. As we can see here on this view, there's quite a lot of relationships here, so we need to figure out a more generic way of dealing with layout. We didn't want to hard code behaviors again, where one component and another were strictly tied together. We wanted them to be fully decoupled. So layout really has two pieces to it. The first part is the size of something. So we introduced a preferred view size API where the component can return to us what size it would like to be. And then we would use that as input into our collection view layouts. And the second part is the relationship between elements in a view. And for that, we introduced something that we call layout traits. What are layout traits? Well, they're a way to more abstractly define how your component behaves in terms of layouts. So instead of saying, I want to have 15 pixels margin to the left, 17 to the right, 10 to the top, we instead just define how the component behaves in a layout. Is it full width, or is it compact width? Is it stackable on top of other components, or is it not? Does it want to be centered, etc.? And that way, we can fully decouple all the margins and all the layouts and put them in a centralized system where we compute it. So that way, we can enforce consistency in our app while still having the components be super atomic and not really have any relationships with each other. So we're going to use the preferred view size and these layout traits to compute the UI collection view layout, and that's what we're going to use for rendering. So that kind of touches on the model layer and now the view layer as well. The third thing we need to talk about is the logic. And for that, we built a declarative API. So declarative programming is becoming more and more popular, especially on iOS. You can see a lot of teams moving towards some form of declarative way of building things. So what is declarative? Well, it's a way of just describing what you want to do and just returning it in one go instead of running all these empirical statements which have a lot of different logic inside of them. So if we look here at what we already have, we see that we already created the component models and the components to render those models. So we have already solved kind of the UI part of things and the model layer. So we now have the ability to actually just render something on the screen. But just rendering something is not the final thing. Like, we need more things to build a UI. First of all, we need logic to load some kind of content. We can't automatically infer what content we want to display. We need to run some code to determine that. And the second thing we need to do is we need to respond to user interactions. It's very nice to have a nice-looking UI, but if it's not interactable, well, it's pretty boring. You can't scroll it around, you can't click on stuff. You know, users won't use it for very long. So in order to deal with both of these problems, and in order to build this declarative API, we created what we call content operations. So content operations are a way to just define what content you want to render inside a view in a declarative way. So just like any other operation that you might be familiar with, they have input and output. And the input is a view model builder. It's an object that we can use to build the content of our view in the code. And the output is the content that we're going to add to that view model builder. Now the great thing here is, since we're using the operation metaphor here, we're free to do work in pretty much any way that we want. We can do things like call our backend inside of a content operation, download some JSON maybe, or whatever format we like, and then add that content to the view model builder. We can also observe some of our core data models and maybe create some KVO to update our content operation every time the model changes. And that way we have a nice reactive way of building things as well. Another thing that is great about operations is that they're chainable. You can just put them after each other. Just use like when you're using NS operation queue or Grand Central Dispatch, you can easily create queues of content where each operation does something very specific, so you don't have to scatter your code all over the place. So if we look here at how content operations fit into this kind of way of doing things, we see that content operations, they declare what models that we want to render. And then the models will be rendered using components. So 3 key things that we did. A shared data model that was more generic and wasn't tied to our core data models, so that our UI doesn't have to be model aware. It can be fully decoupled from our model layer. We then created protocol-oriented views to bring protocol-oriented programming into the UI development world. And finally, a declarative API that enables us to easily define what content that we want to render in an easy way. So we did all of these 3 things, and we worked on it, and we did it as good as we could. And what we did was that we took all of it and we put it inside of a framework that we call the Hub framework. So the Hub framework is a way to build more like hubs of content instead of just building these very, very hardwired view controllers. You now just have components that you put together in an easy way. And what I'd like to do now is to just give you a quick demo of how this is to work with and how it is to build an app using component-driven UIs. So I'm the crazy guy who's going to build an app in front of, I don't know, 100 people. So that's going to be fun. All right, so let's jump into Xcode. Let's just first mirror the screen. And there you go. Now we're in Xcode. So what I've done here is that I've created just a very, very simple app where we can see here that we have our framework, and we just have an app delegate. We have some components that we can use. We have our core data models from before. So I thought, what would be a great example of an app to build here for you today? Well, let's just build the UI that we had before from the presentation. Let's just build this beautiful cities app that displays all of this content right here on the stage. So we have the models here. We have the models for the image that we have on the top. We have the city model with the name and the country from before. And then we have the user model as well with the name and the image URL. You can see I've just added some convenience APIs here just to make things a little bit easier for us here when we're building this so that we can load all of these models. So what I've done here is that I've created just a single content operation for this app, because it's very simple, which is going to load and add the content from our models into our view. So if we run now, we can see that we don't have any content yet. So let's just go ahead and run this app here in the simulator. And we're going to just see, a blank empty view. There is no content there yet. So this is what we're going to do now. So let's start. Let's take a look at our design spec again. We can see the first thing we have is 2 images on the top. So let's start by adding those. So what I'm going to do is that I'm going to first just load these images. So I'm going to call this convenience API from before, image load all. I'm going to create an enumerated version of that array because I want to have access both to the image and the index of that image. And then I'm just going to use a for each call where I'm going to get the index and the image as input. And in this closure, where I'm iterating through all of the images, I want to create a component to represent that image. So let's do that. So I'm going to say image builder, and I'm going to call the view model builder and ask it for a component builder. So it's going to be builder for body component model with identifier. And for the identifier, I'm just going to say image and then give it my index so that I have a unique identifier for each image that we have. The next thing I need to do is specify which component do I want to render using. And to do that, I'm just going to set the component name to be default component names.image. That way, I'm going to get an image component to render my image. It seems appropriate. And the next thing I'm going to do, or final thing, is that I'm going to, again, on this builder, set the main image URL to image.url. And that's really all I have to do. What I've done here now is I've just created this builder here. I've set the component name, and I've set the image. And if we run the app now, go back to the simulator, we can see that we have our images here. So they've just appeared. It's almost like magic. So that's pretty nice. All right, let's keep going. Let's add our cities now. So to do that, we pretty much do the same thing. We call city, load all, and we get all of our cities. But in this case, we actually want to display 2 segments of cities, right? So if we look again at the design, we see we have a couple of cities here on the top, then we have some users, and then we have some cities on the bottom. So I'm going to split this array into 2 pieces, and then I'm going to enumerate that and run for each on that. So that will give me the set index of whether I'm in the top or the bottom, and it's going to give me the set as well, the set of images. So I'm going to run through that. And then when I'm in this loop here, oh, I need to type in as well, sorry about that. When I'm in this closure here, I want to, again, iterate through the set to add the cities. So I'm going to say set, enumerated again for each, and I'm going to get now the index of the city and the city model as input. And here, I'm going to, again, do the same thing as I did for the image. I'm going to create a component builder, set the component name, and set the content on that component. So I'm going to say let RowBuilder, because we're going to use a row, is viewModelBuilder dot builder for component with identifier row. And here, since I need to give it a unique ID, I need to have both the index of the set and the index of the city, just to make sure that it's unique. I could, of course, use a NSU ID or something, but I wanted to make things readable as well. So I'm just going to use the set index here, and then I'm going to use the index for the city itself. So that will create the row builder for me. And then I'm just going to set the title of this builder to be city.name. And RowBuilder.subtitle is city.country. So again, you can see here we're just mapping the core data model properties to this more generic component model instead, so that our UI can understand what that means. So let's go ahead and run this again. Now we're not going to have the 2 segments just yet because we haven't added anything in between. So we're just going to get everything here you see in a big long list because we're just enumerating through all of these. But let's go ahead and add these users here in the middle. So I'm going to do that. So here, after I've enumerated through the set of cities, I want to check if I'm in the first set, I want to add the users. So that way they're going to be below the first set of cities. So I'm going to say if the set index is 0, then I want to create a user builder. And for that, I'm just, again, going to ask the viewModelBuilder to create a component builder for me. And I'm just going to say user. But first what we need to do is load the users. I'm getting ahead of myself here. So we're going to say user load all, same as before, and enumerate through that for each. We're going to get the index, and we're going to get the user as input parameters. Let me get some nice spacing here as well. There we go. And then I'm going to create this builder here. And then I'm going to set userBuilder.mainImage, just like we did for the image above. And I'm going to say user.imageURL. And let's run that. And we're going to see what happens. You can make it slightly bigger so we can see what's going on. Well, we can see here that we get a image here, but it's not really what we wanted. We wanted something that was circular. And we can also see here that I forgot to add the index, so we only actually get 1 component. That's not nice. So let's run that again. You know, demo effect. It's always something that goes a little bit wrong, but no worries. Yeah, you can see here we get all our images here of our users, but they're not the style we wanted. We wanted them to be this nice circular image instead of this row. But you know what we're going to do? Let's just build that component, because that component doesn't exist yet. So let's do that. Let's go here to our components folder and create a new file. And to do that, I'm going to use a template, because we actually, from the framework side, have a lot of templates that we can use, so we don't have to build everything from scratch. So I'm going to select component with images here, and I'm going to name it circular component. And I'm just going to pick a destination for my file here. And we can see now that I have a component class here with the layout traits and everything that we had from before. So I'm just going to go through this pretty quickly. I can show you some more later if you want, just so we don't run out of time. So first of all, I'm going to create an image view for my image. So that's going to be just a UI image view. And then I'm going to load, in the load view, I'm going to assign my image view to my self-view.property. So I'm just going to say self-view equals image view. That way, I'm telling the framework that I want to use my image view for my component view. In preferred size, here is where I'm expected to return the preferred size for my components. So here, I'm going to calculate what size I want to have. So to do that, I'm going to create a metric variable where I'm just taking the container view size, and I'm just, let's see, I have a little bit of a utility here, which is called divide. Oh yeah, I need to say container view size width divided by, and then I can select what, how much I want to divide it by. So I want to divide it by 4 here, and for margin, I want to use component layout manager.margin, so that I get some nice margin on the side as well. And then I'm just going to return a CG size with that metric for both the height and the width, because I want the image to be rectangular, or I want it to be circular, but I want the width and the height to be the same. All right, so the next thing I need to do is I need to return what size I want my image to be. So right now we just return CG size 0, which is going to result in no image at all. But the great thing is that in order to just get the size here, I can just call the method I created earlier, which was preferred view size, because I just want the image to be the same size as my view. So I can just give it the model here and the container view size, because we get access to all this information in both of these steps, which is quite nice. All right, a few more things that I need to do. I need to actually also set up my image view so that it's masked, so I get this nice circular shape. So in order to do that, I'm going to say imageview.layer.corner radius. And in order to get it dynamically, I'm going to move this code here down to configure view here, so I get all this information. And then I'm just going to call this API again, preferred view size, so we can just have everything be derived from the same source of truth. And then I'm just going to give it the model and the container view size here. So I get the preferred view size, and I'm just going to say width and just divide that by 2 so that I get the nice circular image. And I also need to say imageview.clips2bounds equals true, because otherwise the drawing is going to go over the bounds of the view. All right, just one final thing I need to do to finish up my component here is that in update view for loaded image, and this is something that the framework will call automatically, I just need to assign the image that I get to my image view. So I'm just going to say imageview.image equals image, just to get my image assigned back. So, and that should be it. So now what do I need to do in order to get the framework to know about this new component that we just created? Well, I just go to the component factory. And you can see I've already prepared a constant here for it, which says component names.circular, just returns nil. Well, let's just return our circular component that we just created, and that should be it. Now, we just have to go back to our content operation and tell the framework that we want to use this component for this piece of data. So we're going to say UserBuilder dot component name equals default component names dot circular. And let's run that. And pray to the demo gods that this will work. And there we go. It worked. That's awesome. So we have our images there. All right, we're actually finished. Isn't that crazy? We just spent like 5 minutes here. We built this UI. So I think that's pretty fun. So let me just show you one last thing before I wrap up. So now that we have this UI here, it turns out that when you do things declaratively and when you have kind of your model and your content drive your UI, you can do some pretty cool / crazy things. So your models, they're serializable, right? You can serialize your models. That would mean that since we're using a view model as our source of truth, we could serialize our view model and actually just use that serialization to represent our entire UI. Wouldn't that be crazy? Wouldn't it be crazy if we can build the exact same thing as we just spent some time in code building, but we do it using this JSON file instead? So we have a content JSON file here describing the model, the view model, and we just render that. Let's go ahead and have some fun with that. So I'm going to run a command line program here that's called hub live, which you saw some things blinking there maybe. So something did happen. What happened? Well, instead of using, it looks exactly the same as before, but instead of using our native code from before, this UI is actually now powered by this JSON file. And let me prove it to you. So here we have beautiful cities. Just to do a little fun thing, we can just remove the cities, save the file, and the title is updated. We can go back again. We can even do things, let's say the designer says, you know what, this images idea that I had from before, it was great at the time, but I've changed my mind. Images are so 2015. We need to remove the images. Okay, you say, let's go ahead and remove the images. And you save, and you're done. And let's take the images back, and save, and they're back. So we can iterate on UI so quickly now because we just have a declarative API that we can derive from our content itself. We can even do things like introduce brand new components. We can do, up here, we can put a new dictionary here. So what I wanted to do was, so you can see here in the bottom here, we have Oslo, right? Seems bad that Oslo is in the bottom of this list. We're in Oslo right now, right? And Oslo is an awesome city. We should feature this a bit more. So let's go ahead and go down here, take Oslo. Where is it? There you are, Oslo. We grab that one. We can save just for fun. We see it goes away. And up here, we just put it up in the top instead. Well, now it's a little bit more featured, but we can do better than that. So what I'm going to do is I'm going to change the component ID here. Instead of being row, it's instead going to be promotion, because I really want to promote Oslo. And I'm going to give it an image. So I'm going to say images. I'm going to say main. I'm going to say the URI. And the URI is pretty much the same as down here, but instead of Tokyo, we're going to say Oslo. Again, save the file, and boom, we now have a promotion for Oslo in the top. Thank you. So that was just a quick example of how you can use component-driven UIs to move really, really fast and to just mix and match the content that you have and have your UI be updated actually without even compiling if you're just changing the content, and introducing new components we could do in a matter of minutes just because we have this protocol-oriented approach. We don't have hard-coded types anymore. So I've spent a lot of time this year to talk about this thing in various conferences because I am really, really passionate about this topic, and I really think it's a pretty big game changer. It's been for us at Spotify, at least. And the number one question that I've gotten when I've done these talks is, you know, this looks great in the demo, but we want to dig into the source code. We want to see how this thing works. How does it really, everything come together? Well, I'm actually very, very happy to tell you that the Hub framework and everything I showed you today is completely open source. So you can go and play with it right now if you want. And not only is the framework itself open source, well, the live editing tools are open source as well, everything that you see. And we also open sourced our entire roadmap so you can see what we're working on in terms of the framework as well. So it's completely open source. All right, so thanks a lot for coming to listen to me today. If you want to stay in touch, I would love that. My name is, or my alias on Twitter is @JohnSundell. I'm on GitHub as well at John Sundell there. And I also have a link on my GitHub profile to the Hub framework in case you want a quick shortcut. You just see there I have it as a pinned repo. And that's it for me. Thank you very much.